now it looks like my computer needed to be like fixed, so we'll see here. I might just go on the whiteboard just see how it goes. Sorry, we're moving you. Okay.
No, I ate it. Because I was like, there's no way I'm not eating. The pumpkin cheesecake.
Okay. So I'm trying to get the glare down for them. Okay. So square root of 36, if you put that in your calculator, square root of 36 is 6 because 6 times 6 is 36. So if you did that one, hopefully that's something that you guys knew already. That's the idea with that square root. Now square root of 20, again, if you put that in your calculator may tell you a decimal value. So say like 4 point something, because like 4 point something times itself will give you 20. So again, it's square root of 20, and you get like 4.47. We want instead what we call a simplified radical. And so some of your calculators just give you the answer of 2 square roots of 5, right? So this is what I'm looking for. Now, if your calculator doesn't do that, I have to show you how to do that. Or you can find someone to use that calculator for a day. I can't have you guys like passing calculators back and forth during a test. So there are a lot of those types out here. But square root of 20, what they're basically asking you to do is break it up and try to pull out any perfect square that you can. So when I talk about perfect squares, I'm talking about numbers like square root of 4, square root of 9, square root of 16, square root of 25. These are all perfect squares. So I try to find numbers like these that go into 20. So out of this list, 4 is one that actually goes into 20. So I break this up as square root of 4 times the square root of 5. So square root of 4 times square root of 5 is square root of 20. So what we do then is I can take the square root of 4 and I get 2. So when I do the square root of 4, that's where the 2 comes from. Like I can take the square root of 4, it gives me 2. Square root of 5 is not a nice number. Square root of 5 is like 2 point something. So we're just going to leave this. This is considered a simplified radical. 2 square roots of 5. And it's strange. I mean, you're kind of like, why would you do that? Why is that helpful? And we end up learning why later on. We'll use a lot of these simplified radicals in this chapter. So being comfortable with those radicals. So again, and I do have a few of these. So like if you wanted to swap out yours during a test or even during homework and want to work with it, that's fine with me. I'm not going to like stop you from using that calculator if you have it or can get one. But it's really nice for simplifying radicals, which is something we do a lot in with triangles and with trigonometry. So as you guys move on in math, those calculators really come in handy. So that's actually the one I think we recommend like on our website for that reason. Now I've also been at schools who like think these are like evil because they give you the answer, but it's fine. So it's not like you're doing that in the grocery store or something. You don't need to know how to do that by hand. So the next one is square root of 48. Dang it. I don't know if it's going to work today. Oh, no, it is. Okay, I just need to be patient. Patience is not one of my virtues. All right, the next one is the square root of 48. Now, again, if you don't have one of these fancy calculators, we have to figure out the number that goes into 48 nicely, that allows us to simplify the square root. Now, one of the things you might notice is 4 goes into 48. However, there's a bigger number that is a perfect square that goes into 48. Do you see it off this list? You might not realize it. So let me start with 4 and show you how that looks. I break it up as square root of 4 times the square root of 12. Well, square root of 4 is 2. Square root of 12. However, square root of 12 can be broken up more. So we can break this up, 4 times 3. So I take the square root of 4, I get 2. And then square root of 3, and multiply those. So what I'm trying to say is there's a faster way to get to this answer. So I'll show you that here. What I was trying to get you to see is square root of 48, 16 actually goes into 48. So if I can break this up with a 16, sorry, that marker doesn't work very good. So if I can break this up as square root of 16 times 3, 16 times 3 is 48. Square root of 16 is 4. So I get the same answer in a lot less steps. So, yes.
Okay, so, I don't know if we learned this when we were virtual, but like for the square root of 48, doesn't that have to be like one number? Because then we have square root of 4 and square root of 12. And doesn't that the square root be actually like the same thing times the same number?
Well, 4 times 12 is 48.
But don't they have to be the same number?
No. Oh, I see what you're saying, because like square root of 36
Yeah.
is 6 times 6. Yeah, but there's no number that's a whole number that will give you 48 that multiplies by itself.
So you have to do them and then
And then
square it up.
yeah, you take whatever perfect square out. That's why we have to do this, is because it doesn't work nicely this way.
And then I get from like the square root of 4 and square root of 12 to 2 and square root of 12.
So I took the square root of 4, which
Yeah.
is just 2.
So then
So the square root goes away. What's that?
Don't do that to 12.
Well, square root of 12, if you try that in your calculator, it's going to be like a decimal. So we don't want decimals in here. So we're trying to avoid those decimals. So I left square root of 12 as like a non-perfect square, and then I broke it up again. So we kind of keep trying to pull it out, almost like a simple, just like if I said, hey, you should simplify, I don't know, 12 over 14, and you simplify it as much as you can. You don't want it as a decimal, you divide by 2, you divide by, you have to keep going. It's the same idea here. We're just trying to simplify the radical as much as we can to get the smallest number possible underneath the root.
Okay.
And you guys, honestly, if this flies right over your head and you really don't want to, then make sure we have, make sure you use the calculator. I mean, there's your classmates in your other geometry class probably have these. I would just try to find someone that you can use theirs. Because this simplifying radical, it doesn't come super easy. I mean, we're going to work with them more often and use those quite a bit. And then the square root of 400 happens to be a perfect square. It's just 20 times 20. So we just write it as 20 then. So you don't have to do anything crazy with the square root of 400. Oh my gosh. So, you guys online over here. So now my computer's finally working. Yikes, it's in my computer it's hasn't been updated in forever apparently. All sorts of crazy stuff. Oh my gosh. Yeah. So again, when we do these, I want an answer with the simplest radical possible. So square root of 400 is just 20. Square root of 36 is just 6. But these other two, since like what kind of Michael was asking about, since those don't have a number that a number times itself will equal 20, that's not a decimal, we just simplify those radicals. We write this as 2 square roots of 5. Because 5 is as small as we can get underneath the root there. This one is going to be 4 square roots of 3. So again, however you guys get to that point, we have to be comfortable with using those simplified radicals. And we will have that as part of our homework today. So just, like finding a way to do that, I'll practice it a little bit more with you guys. It is a tough idea, but being able to simplify those radicals are going to be helpful as we move forward with geometry, but also with trigonometry, which we will do a little bit in here. So we've talked about the Pythagorean theorem before. We actually talked about it a little bit the last couple of sections or chapters. But now we're really going to get into it a little bit deeper, using it in a lot of different ways. So now I almost always tell my students when they're going in to take the ACT, if you don't use the Pythagorean theorem somewhere on the ACT, you've definitely gotten a few questions wrong. You should have gotten right. Pythagorean theorem is a favorite on the ACT. So again, if you don't end up using it somewhere, something probably went bad. So Pythagorean theorem is that a squared plus b squared equals c squared. C must be the longest side. Now, how we're going to find that longest side is it's always across from the right angle. Which we call the hypotenuse. So the C is super important that it has to be across from the right angle. It has to be the longest side, so C matters. So where we put C, it has to be across from the right angle. A and B don't really matter. They're kind of interchangeable. So A and B, it doesn't really matter which one it is. But C has to be in that spot across from that right angle. So we're going to do the Pythagorean theorem quite a bit today. I think for your homework, it's going to ask you to simplify the radicals as we go, because there will be square roots being involved here because of the fact that we have squares. So in order to solve those, we're going to need a square root. So I know you guys have done a little bit with Pythagorean theorem. We've talked about it a little bit here and there and here. So kind of showing you guys a few examples of kind of different problems involving Pythagorean theorem. And so this whole front side should kind of be review, or something you've seen before, kind of seen. So like in letter A here, which side has to be C? Where does the C have to be? X. It has to be our C is our X, because it's across from the right angle. A and B don't really matter which one I call A, which one I call B, but C has to be X in this case. So we're going to set up our formula. So we have 8 squared plus 7 squared equals X squared. So I'm just putting all those values in. Now 8 squared, again, so having a calculator handy is helpful just so that we're not making a silly mistake on squaring something. 8 is 8 times 8, not 8 times 2. That's probably a really common mistake that comes up. So this would be 64, this is 49, and then I add those together, and I get 113, yeah. So the length of X isn't 113 though. That would be way too long. I would hope you'd look at that and be like, whoa, that wouldn't even form a triangle, much less a right triangle. So in order to find the value of X, what do we need to do? Square root. So that's where that square root comes in. So I do the square root of 113 is going to be my x value. Now those of you guys who have the fancy calculator, what do you guys find out about the square root of 113? Yeah, it's not even able to be simplified. If you put that into your calculator, that means that no perfect square even goes into 113. I actually think 113 might be what we call a prime number. It can't even be divided by anything other than itself or 1. So that would be the value of x. Now, if you're like, again, you're like, yikes, that just doesn't make sense because that's a really big number. If you actually take the square root of 113, it's going to be about 10 point something. And those of you guys who have the fancier calculator, if you're ever wondering for that decimal value, you hit the little button that looks like, it looks like this. So if you want to know what that decimal value is, if you hit that button, it'll tell you the decimal. So it'll tell you it's like 10.6-ish. So if you're wondering, like, my answer didn't make sense, or if I'm trying to figure out how long that piece is, or whatever it happens to be, that's about 10.6. And you guys will probably, I mean, maybe think my relationship with my husband's really boring or what, but so geometry actually comes up from time to time. Every once in a while, I got a text one day from Mr. Donahue that said he was trying to figure out the length of the outfield wall in the baseball diamond, like, because he wanted to be able to cover it all with tarps, you know, so like the baseball diamond. It made me think of this because, you know, like, so he wanted to cover the outfield wall and he wanted to know how long that wall was. And so it's geometry to figure that out. It's just a part of a, you know, arc of a circle. Kind of same idea here with finding the length of a hypotenuse of a triangle. It's something that might come up. I mean, that's not like that absurd to have to think about. You're building something and wanting to know the length of that piece of wood that you need to use, or like I said, the tarp across the outfield wall. There is some geometry required there. So he wanted me like to drop everything in that minute and tell him that measurement, but I was like, give me a minute, I need like to write something down here. But so there is geometry involved, especially with triangles, with circles, with trigonometry is something that can be used quite a bit. So you might want to know about how long that is if you were actually doing a measurement. So why don't you guys try letter B if you haven't already? I actually think letter B might be another one that's like not simplifiable. You might be able to leave it. Okay, so hopefully you realize C has to be our X again in this case. And then our A and B can be either of the other two, it doesn't really matter. So I'm going to do A squared plus B squared equals C squared, which should be our X squared again. Careful, 3 squared is 9. And then 10 squared is going to be 100. So I get 109. I go to take the square root. Actually ends up being a really close number to that last one. And we get the square root of 109, which is again about 10 point something. That won't always be the answer. But I don't think 109 simplifies either, does it? I don't think so. So kind of pick some bad ones in terms of practicing simplifying radicals if we wanted that. But again, I get about 10 point. This one's probably closer, a little bit smaller number here. So 10.4 for that length of that side, if you wanted to know the approximate value. So this would be considered the simplified radical if I wanted the approximate value, it's about 10.4. So kind of showing you those different options for answers. Now, C and D are a little bit tougher because this time you don't know, you're looking for a side other than C. So if you look at this time, letter C, we don't have the missing hypotenuse. So the C value in this case is actually 26. It makes it a little bit tougher to solve, not much, but still like a few more steps or an extra step or two. So I'm gonna call my A my unknown in this case. So A squared plus B squared equals C squared, so we have X squared plus 24 squared equals 26 squared. Some bigger numbers, probably not something you knew off the top of your head. So then I want to solve for X. So what are we going to do? Subtract that 576. We're trying to get X alone. Well, 676 minus 576 is 100. And hopefully that's one you know off the top of your head, but if not, use your calculator, it's fine, until you get comfortable with these. We're taking the square root of 100, which will just give us 10. Makes you think all the answers are 10-ish, but they're not. So. And then finally with our letter D, and then we'll take a little break here. So again, we don't know, this time the C value is given to us. And again, our A and B, and again, doesn't matter which one you call A and which one you call B. I usually just go like from left to right, but it doesn't really matter. So 12 squared is 144, sorry. Squared, it's like 256 or something like that. Yeah. Once I have that, again, I can move this over. Again, our answer is about 10. Now this one, does that simplify? It might simplify a little bit, right? Is it? No? Yeah, so this one is when we want to simplify. So, now again, if you don't have one of these fancy calculators, it's going to be hard to be able to tell when you can simplify and when you can't. I'm not great at it either. So again, when we're looking for that, we want to try values that go into it. And maybe sometimes even starting at this list, and trying to find the biggest number that goes into it in terms of the perfect squares. Like checking, does 36 go into 112? And when I say goes into, it means divides into evenly. So if I do 112 divided by 36, no, it's like 3.1. 112 divided by 25 doesn't work. But 112 divided by 16 does. It's 7. So what I did then is I found a perfect square to use to break up that 112. Now, had you not noticed that, maybe you would have used the 4, and then you would have had to do 2 steps here. But 16 goes into 112, 16 times 7. Now, square root of 16, I know the answer for that. Square root of 16 is 4. Square root of 7 is not a perfect square, so I'm just going to leave that as a perfect square. So this would be considered my answer, 4 square roots of 7 if I want it as a simplified radical. However, if you want it as a decimal, again, we have that around 10-ish, of course, because everyone in this one was about that. It's like 10.6. But 4 square roots of 7 is considered the simplified radical. All right. So what do you guys want to do as a break today? It's up to you. You haven't been in school for a while. Should we do A fun Kahoot, a Pictionary, what do you guys wanna do? What do you think? Any preference? No? I don't care what we do, to be honest. Oh! It's a little chilly to go on a walk outside. Yeah. Alright, why don't I find like a non-math related Kahoot and we'll.
Yeah.
Hold on. Streamer? Yeah.
I mean, that's less even than Disney on us.
But I might have to pick up on your mom's.
We're gonna be there, yes.
Give me the poly.
You guys know enough about like different cartoons, yeah, you guys. If you absolutely do not want to play, it's up to you. You don't have to, but just chill for a moment. This one's on like the Kate suggested DreamWorks, so like cartoons probably that you guys know or seen at some point.
Yeah, I can't play it.
Why?
Because it's on my laptop.
Oh no.
It's terrible because I don't have a laptop. Dad.
Bro, I'm not. Actually, I am. Mike is. I don't want to log in. I just want to play. That's what makes sense. Yo, which Michael? Hey, look, I was gonna be Michael.
Do you guys comment on this?
The real
Steelers comment
Michael.
said, what color you think it?
is
Yeah, so then he got his new black.
And those of you guys online, obviously this isn't live for you anyhow, so.
7, 4, 4, 6.
First time we're here. No, oh, you should have done that.
Yeah.
All right. We're gonna start. You guys are hopefully ready.
There's some fakes around here.
I don't know.
You guys are just trying to be me.
You might know these, I think. They would not come through.
And when the phone turned off.
Oh,
But then I saw.
Whoops.
Bro, I didn't really watch movies.
I didn't watch.
I just, I must get stocks.
Okay.
And does it count if I want to?
Can you see them? Yeah, he
I
is
love
You guys didn't think you knew.
Oh. What are you
I'm
doing?
sorry. I got it right.
Oh, geez.
What, Thomas?
No, no.
I think
Maybe
that's
it's kind of
right?
like-
1997.
Let's go.
I feel like it was gotta be more recent. You think it's older than that?
It's literally
You
over.
got it wrong too.
Hey!
Let's try it. Come on, Michael.
We have no muscles up there. What is up?
Oh my god. But you've never seen the movie? Oh
I
my.
got it, yes.
Girl, you got it bad.
I know. That's right. Yep.
Everyone's right.
Oh, that might be too young for you guys. Eh?
What is it?
It's definitely.
Oh. I didn't watch Trolls. Oh. I just went down to 3 things.
Yeah, I'm coming
There
up.
you go, Michael. Gotta get him.
What is up? Oh, God.
I don't know that one.
2008.
There's no way that's after.
So think about how old you were maybe when movies came out. Are you
I'm sure when it comes.
What year were you guys born in?
Oh.
Yeah, so that's old for you guys.
It's not that old. It's not-
Let's go. Let's go.
You're welcome.
We cruise.
It was an acted film, The Cruise.
True, huh?
Yeah.
They're coming out with the second Cruise.
Yeah, yeah. Like, who made this?
But they're,
More mics. More locals.
my sons actually had an argument about The Cruise the other day, because they were trying to decide, one of them likes it and one of them doesn't. So.
I never watched it.
Someone didn't have a childhood apparently over there.
Well, that movie came out like
Stem
2
was
years
busy
ago.
not even. I'm
It's
insane.
not much sweeter though. It is definitely not like fifth grade. What?
2013.
I don't know that one.
That's
Oh, there's no way this is.
What is this?
Apparently it was a blockbuster.
The world definitely ended. I don't know.
Which is make a good guess or be really good at Google.
Other world. I don't think anyone ever watched it.
I don't think so either. I've never heard of that.
Oh,
What?
Oh, I'm just thinking of
Let's go.
Who knows years that movies came out?
Yeah, like it was just like searches.
Well, Michael had been here. He'd been Googling it. Michael
Oh my God! Let's go.
Let's go,
Let's go,
boys.
let's go.
Represent.
It's not as.
Sorry, I didn't know.
Oh,
Oh,
that movie's actually really good.
I like that one a lot,
That's
too.
very good.
Well, I got that.
The aliens so cool.
It like has a good soundtrack even. Like this is.
Yeah.
Oh,
That's right.
Let's go.
Stone, right? Stone.
I'm still up there.
What? Why did they keep? I'm sorry they keep asking me years. I didn't think they would do that.
Is this movie the first?
Yes.
I don't know.
yes. They said in the commercial.
Oh yes.
You
Oh.
always just answer yes.
Oh, right. We'll not use this food again. Finish. See, these were the questions I thought we would be getting.
Well, I was expecting a sentence.
Yeah, that's not a very tough question.
I was literally just looking for Fiona.
During the daytime, she's Let me just say,
What?
So is that a DreamWorks?
That's
Oh.
Are you kidding me? You went down? You're in 6 now?
13th actually.
That's.
No, it's not, I mean, actually.
Isn't it an N? I always thought it was just N.
Like and?
Yeah, right. What's so funny? You guys are so.
I know, she is.
I'm a little more.
Oh.
Yeah.
Lost, baby.
Yeah.
Yeah, of course, happy. This is the one.
Yes!
Oh, I'm sorry.
Oh, this movie's so good.
It was not a pretend movie.
Oh, I got it wrong. Now I'm gonna be a last one.
You better not.
Oh, I got it right. It was not.
It was not a pretend movie, so false. So it was a pretend movie.
Why did they word these? so
I don't know.
weird?
You're bad. That's what I get for just finding a.
What is turbo?
What?
What?
An animated movie of
What?
Is that even a sentence?
Dude, I feel like a second.
it's definitely a Potter and Stone production.
It's not bad.
Hi. We're like twins today.
Have you ever seen this? Yeah, that's right. Yeah, that's right.
Okay.
We can still do this. We got this. We got this. Come on.
Stone. Alright, so five, come on up. No worries, no, it's okay.
If you get 6, and if you.
Yeah, I
got it.
know.
You get it. If you get. I got it. I should got it.
Yeah, you got it.
But then I should have got 7.
I'm saving this for lunch.
The rest of you guys can come up and grab this sucker. I need to use it.
I guess I'm playing it in all of my.
Dude, go get your supper. Just stop.
There was 3 rifles on the board, Michael. It's 3 suckers.
You did what?
What was the question?
We can do much better.
I know.
Dude, you have like.
I'm sorry. It was confusing.
Hey, maybe if you drafted me first, right?
I was like, who is that number? Who is that?
Yeah.
Who else is it? I was drafted second
You could
round.
have drafted me first, but I'll think about it.
Michael went undrafted.
I'll make a good draft.
Yeah, we got drafted first round.
Yep,
Michael went undrafted.
independent.
Yeah.
No.
United Michael of America.
Okay,
With your, yeah, cancel. You need to cancel.
Cancel.
I dare you to try and cancel. Be like, guys, he's always reading.
No, we canceled Jack and Noah lives.
Really?
He was kind of salty.
okay, oh, sorry.
Look up. It sounds like that, Jack.
I forgot to print some notes off, but I'll.
Catch
up here. All right, so we're on the back side, you guys.
Oh.
There are 2 Michaels in here typically, but I'll send it.
So.
He already has a story. So. I don't know, he apparently knows why he's being called out.
So, you know, he's out there now, so I'm the bad famous.
Like when you go find your mom before your brother does, so that like you can like tell your side of the story first. Like, so mom. All right, so a Pythagorean triple. If you guys didn't hear me, if you guys want to grab a sucker, you can. It's basically they're really nice numbers that work nicely for a triangle. So they're whole numbers. Yeah.
Just go.
So there are whole numbers that work for our Pythagorean theorem. So they're numbers that we don't have to do any kind of simplifying of radicals, they just work nicely. They're called Pythagorean triples. They're great time savers, probably more than anything. And Pythagorean triples, like I mentioned the ACT before, Pythagorean triples show up all the time on the ACT because they're a time saver, and so if you know them, they like that you realize that, and they kind of like it's like a little bonus, gives you extra time then on the test. So it's the three sides that form a right triangle. Now, there's infinite number of Pythagorean triples, but some of them are more common than others. So the one that's the most common that you'll probably see me use the most often is a 3, 4, 5. And I'll show you guys what I mean by that. So it goes 3, 4, 5. So these are the side lengths. And the reason why this works nicely is this means that 3 squared plus 4 squared equals 5 squared. So 3 squared is 9, 4 squared is 16, and 5 squared is 25. So 3, 4, 5 is always going to form a right triangle. And so if I'm trying to draw a triangle that I know is going to be a right triangle, a lot of times I use 3, 4, and 5 as those side lengths. However, if you guys recall from last chapter, that anytime, so that's the ratio of the side lengths. We can also double those, and it would also work. We can triple those, that would work. So basically, any combination of this ratio, so 6, 8, and 10 also works. 9, 12, and 15 also work. So any combinations of this ratio also work. And again, it's just a really good time saver. It's not necessarily something you have to memorize. However, if you notice it, you're like, oh, that's one of those Pythagorean triples, I don't even have to really do the math. So like if you drew a triangle for me, that you had 30, 50, and said, what's this third side? I would look at that and say, oh, the third side has to be 40, it's the right triangle, because of the fact that I know that's a Pythagorean triple. Like I wouldn't even have to do Pythagorean theorem. It's just a really quick time saver if you can notice it. Now, if you don't notice it, it's probably just easier to use Pythagorean theorem. And I think as a student, I think I got good at some of them, and then others of them I just never noticed the pattern or wouldn't memorize it. So 5, 12, 13 is another one, and I'm holding this because I'm afraid I'd forget some of them. So same idea, you can double those, so like 10, 24, 26 would also work. Another one is 8, 15, 17. And then the other one that we'll list, but there's other ones out there, is 7, 24, 25. So this isn't an exhaustive list, which means it doesn't include all of them, but these are some of the ones that come up more often. So if you can notice these, it might just save you some time and kind of avoid mistakes. So if you guys look at the next couple of problems, it says, use the Pythagorean triple to find the value of x. So if you look at this, so I have 20 and 48. I don't know the third side. Now I could do Pythagorean theorem. I could do a squared plus b squared equals c squared to find my x. That could work just fine. However, I can notice that this is a Pythagorean triple. Maybe we can kind of avoid doing some Pythagorean theorem and not having to maybe use our calculator quite as much. So what I'm gonna notice here, and I'll just show you guys kind of what you can do with this, is 20 and 48 isn't on my list up there. However, I know these can both be divided by 4. Do you agree? So 20 and 48 can both be divided by 4, right? So if I divide them both by 4, I have a 5 and a 12. Do you see any pattern up there that has 5 and 12? 5, 12, what? 13. So this is a 5, 12, 13 triangle. However, 5 isn't listed, it's actually 20. 12 isn't listed, it's actually 48. So what do I have to do to 13? Multiply times 4. So my x value then is 13 times 4, which is going to be 52. Now, you might be saying, why in the world would you not just do Pythagorean theorem? You could have. So I honestly, if I said, or the book says use a Pythagorean triple to do this, and you got crazy and you're like, no, I'm not going to do that. I'm just going to do Pythagorean theorem. You're still going to get the same answer. You're still going to get 52. It's just you're working with some really, really big numbers. And so if you can use some of these patterns, if they tell you it's going to be a Pythagorean triple, it does save you a little bit of time, maybe. Because obviously 52 is not a nice number. It's a really large number in terms of with square roots, because 52 squared is 2,704. So who wants to work with huge numbers like that if we can kind of avoid it? So if they say you can use a Pythagorean triple, try looking at this list and see if you can come up with it. So this next one, do you notice what 14 and 15 can both be divided by? 2. So I can kind of simplify them to call that 7 and 25. Is there a Pythagorean triple that has 7 and 25? Yep, 7, 24, and 25. So this would be 24, and that makes sense because this is the longest side. So these are all doubled, so this would be 48. So that'd be my x value. But again, had you not wanted to do that, you could have just done 14 squared plus x squared equals 50 squared. But again, you're working with some really large numbers there, and if you know it's going to be a whole number, and you know there's a pattern that exists, you can use those Pythagorean triples. So either way you want to go about this is fine with me. I'm not going to ever take off if you use the Pythagorean theorem. I'm perfectly fine with it. It's just on some of, especially ones with the 3, 4, 5, I would kind of watch out for those and know that you don't have to put them into the Pythagorean theorem every time. All right, we have a few more problems here. Almost done. So this one seems kind of off kilter here. You won't understand initially why this is important in this section. So find the area of the isosceles triangle that has side lengths of 20, 20, and 24. So first of all, what do you guys know about the area of a triangle? We haven't done that for a while. Or maybe haven't done that this year. You guys know the area of a triangle formula? Yep. 1/2 base times height, or base times height divided by 2. So I have to figure out what the base and height are of our isosceles triangle. So again, anytime they're talking about a drawing and I can't see it, I'm going to draw. So 20, 20, 24. And my drawing's not great. So 20, 20, 24. I'm drawing our triangle. They want the area of this triangle. So that means I need the base and the height. The base and the height is talking about, remember, we talked about this a little bit with altitudes of triangles. The base and height has to come from the fact that there has to be a right angle. And I don't know for sure that 20 and 20 would form a right angle. So I'm going to draw a right angle right down the center here. So I need to figure that out as the height. Now, this is my isosceles triangle, and I drew a line straight down the center. What do I know about this line? What's that? It's cut in half. It becomes like a perpendicular bisector. And that's because these two are the same length. So this kind of relates back to last chapter. So this is 24. What do I know about those two little lengths? They're both going to be 12. So I should be able to find the height of this triangle because this is a little right triangle here. Now again, this might be a time you want to check and see is there a Pythagorean triple that goes with this. 20 and 12 can both be divided by 4, right? And so they become 5 and 3. There's a 3, 4, 5 right triangle. So what does the height have to be? 4, but we did 16, yeah. So yeah, realizing that this is going to be a 3, this is going to be a 5, this would be a 4, so it'd actually be 16 for the height. Now, you could have done Pythagorean theorem here, but when there's that 3, 4, 5 pattern, I almost always skip Pythagorean theorem with it when I notice that. So if you can see that and kind of get used to that, it's a really nice pattern to use. So the height is 16, sorry. It's base times height divided by 2, or 1/2 base times height. The height is 16, what's the base? 24, yeah, the whole way across. So it's going to be 24 times 16 divided by 2. And there's one like this on our homework, which is why I put this one on here. So that'll be 192 for our area. So it's the area of that triangle. Okay, and then finally, this last one, the drawing's a little bit bad. They should have a little right angle on the corner here. Should have been drawn already. If you didn't have that, you wouldn't know the rest of this for sure. Actually, now that I say that, let's take that out. We don't know that. We don't need to know that. Never mind. Jokes on us, sorry. That might not be right after all. Okay, how would I find x though then? Any thoughts? There's really 3 triangles here, and really we only know 2 of them are right. I was wrong in saying that third one has to be right as well. It might be, but yeah, go ahead, Stone.
You have to find the length of the highest.
Yeah, it's like this little distance here. I'll just call it like a little a, like maybe an altitude. So that little a, we have to find that distance because then that'll allow us to find x. So we have to kind of solve this triangle first and then be able to use that to find our x value. Now in this triangle, again, watch out for those Pythagorean triples. This is one we just were using. This is 20, 16. What does the other one have to be then? 5, 4, 3. So this will actually be 12. We just used that. So when you see those patterns come up and you're like, wow, she uses this one a lot. Yeah, it comes up a lot and it'll come up in your homework. So that a value is going to be 12 there. Now again, if you didn't notice that, you can always use Pythagorean theorem. Then I have to go over here. And I have 8, 12, and x. Now these I can divide them both by 4. So I get 2, 3. Is there a Pythagorean triple with 2 and 3? No, so they're not all Pythagorean triples. So I was able to find the 12 with Pythagorean triples, but this one I'll just have to do Pythagorean theorem, which is fine, but it's kind of worth checking on. So I'm going to do 8 squared plus 12 squared is going to give me x squared. I already know this is not going to be a whole number answer as far as I know, because of the fact that it wasn't a Pythagorean triple. 208, that's my x squared. Now 208, I'm assuming can be simplified. 4 square root of 13 is my 208, or as a decimal, it's like 14.4. If they wanted a radical, it'd be the top one. If they wanted a decimal, 14.4. Okay. So, homework is listed there for you guys. Again, make sure you guys are staying on top of homework so that you don't have to come on those virtual Fridays. Again, if you want to come during AR today to work on test corrections or to do your test, let me know. I can make sure that your AR teacher knows you're coming down to see me. So homework is listed there. It should be online, I think.